Hi everyone. Good afternoon, guys. Very good afternoon, everyone. How are you all? Everyone, how are you? So we are starting the class little late because actually I was having some press class, that highway course. It was supposed to be completed. That's why I'm starting little late. Right. So everyone, how are you? So all of you had your lunch. Everyone, your lunch gets over or not? All of you. Your lunch gets over, everyone. I could not see the comments. One sec. Right. So here we'll be continuing our discussions on which one. This is strength of materials. So quick revision sessions, right? So here we are not discussing the entire subject, right? But what we will be discussing, you can say, we will be discussing only the revision part, right? Quickly we'll be revising, and so that what will happen, right? You will be recollecting all the concepts of this one whenever you want, right? That is what. So all of you, welcome to Unacademy. Let's crack it, right? Whenever you are subscribing to the Plus and Iconic courses, right? What are the referral code? What is the referral code you have to use? Tell me. RP Civil is the referral code you have to use, right? Now, so this is my profile. You can follow me at which in Unacademy app on Unacademy website. So that is unacademy.com slash at RP Civil, right? Or go to Unacademy website and search RP Civil. You can find my profile, right? You just start following my profile, all of you. And these are all the students, those who secured AIR1 in GATE 2024 from Unacademy, from various branches of this engineering, you can say. And so today will be the last date for this offer, all of you, right? What is the last day for this offer? Freedom to learn and freedom to succeed offer, right? So GATE subscription for this 2025 aspirants, it is for 6 months, but you will be getting 2 months extra. That offer is valid only for today. Tonight this offer will be going to end, all of you, right? So it is at this 8,499. What is that a referral code you have to use? Always RP Civil is the code you have to use, right, when you are subscribing to the Plus and Iconic courses. And so if you are having doubt which kind of subscriptions are there, so one is Plus subscription, you can say. If you are taking 6 months, you will be getting 2 months extra at this 8,499. That is almost more 50% off. Iconic subscription, 6 months if you are taking that, 2 months extra, that is available at which one? This 14,999 rupees, right? So what is that a referral code you have to use? Always tell me. RP Civil is the only referral code you have to use, right, to get which one? This maximum benefits, right, of this subscription. Now so here if you just observe, right, next uh, corresponding to this, right, so we are taking the subscription, right? Are there any batches starting? If I am a 2025 aspirant, if you are having the doubt now, so these are the new batches starting, right, for this 2025 aspirants, right? So 11th August this batch was started. Pratishta batch for this 2025 aspirants it was started. KP sir, right? So you know KP sir, na? So no, KP sir started irrigation engineering at 9 a.m. every day, right? So what is that a referral code? Again you have to use RP Civil. So this Shikhar batch for this 2026 aspirants also was started on which one? This 11th August only. Same irrigation engineering subject only, right? What is that referral code you have to use? RP Civil. Here 7 people are in live. Nobody is responding. Everybody had your lunch or not? All of you. Your lunch gets over or not, all of you? Somebody respond. So those who are taking Iconic subscription will get these printed books delivered to your home within 15 days of your subscription, you can say, right? So this topic we have done on this 12th, na? Every alternate day will be doing which one? Every alternate day will be taking which one, you can say, will be taking this uh, YouTube session, right? YouTube live session, right? Next alternate days, right, we'll be taking which one? These other sessions, right? Special class, right? Live test will be having. Here these are not visible. Okay, stress, strain and mechanical property, stress, strain and mechanical properties we have done, na? So no, this is what we have discussed, you can say. How many points are discussed, right? Up to this 16th point we have discussed, na? Yes or no? Right. Now toughness we have discussed. Today's discussion, if you just observe lecture 2, SOM quick revision only. Stress strain curve we will see, and also what is that you can say true stress and strain also we will see if possible, right, if time available. So this is what you are having. This is your first slide, right? Now 17th point, if you just observe, right, up to 16 points it is over now. Up to how many points we have done? 16 points we have done, right? Now we are going for this 17th point, you can see if you just observe, right? So now stress strain curve for what? Mild steel. Why we are seeing a mild steel only? Why we don't see other materials? Tell me first of all. That mild steel will be your low carbon steel, na? And why we will go with the mild steel only? Tell me. Anyone having idea? Why we don't refer other than mild steel? What is the reason? Anybody guess? Anybody guess? Somebody respond. So here, because this will be giving the detailed discussions of which one is lower yield point, upper yield point, right, plastic, strain hardening, strain softening, every kind of this detail is available in this. Other than this, na, you don't get much details, right? You will not be getting which one, this more details than this, right? That is why this curve, right, mild steel stress strain curve will be more authentic and more detailed compared to which one, this all other curves, for understanding the materials behavior exactly, right? Now here if you just consider, right, what is that you can say for the stress strain curve for this mild steel, this is y-axis is your stress and this x-axis is your which one, this is strain, right? So yesterday we have seen, if you just remember the previous class, what load will try to do. Load is an agent. Load will try to create the strains first, na? Based on the strains only that member will try to offer resistance. Means strain will come first. Based on the strain that load is going to create, that a member will try to develop the stress or this resistance, right? Who will come first? Tell me. Strain will come first, na? Stress is depending upon the strain trying to be generated, right? That is why strain is independent quantity, stress is depending upon the strain. So always independent quantities we have to draw it on which one, this x-axis, na? Dependent quantities we have to draw it on which one, this y-axis, you can say, right? Is it clear everyone, that point? Somebody respond. Is it clear everyone? I think okay, nobody is there in the class, is it so? So up to this point, right, we'll be having this straight line variation, right? After this you'll be having this curved variation, you can say. Then you will be having the curve in this manner, if you just observe. Yes, no? This is what is your curve, right? So now what is this first one? Up to this it is a straight line only, right? This is your A point, you can say. That point A is representing which one? Proportionality limit, right? So what is the meaning of this proportionality limit? Tell me all of you. What is the meaning of this proportionality limit? Proportionality limit means Hooke's law is valid up to this point only, right? What is the Hooke's law? Anyone guess? So stress is directly proportional to this strain, na? Stress is directly proportional to this strain, right? Now what is this B point, you can say? Proportionality limit means, right, if you just observe, this portion will be which portion, you can say? That is your straight portion only, na? That is your straight portion for this stress strain curve only. But here what is that, you can say, right? A to B, it is your curved portion, na? A to B, it is your which one? This is a curved portion, you can say, if you just observe, right? That B will be taken as which one? Elastic limit. What is the meaning of this elastic limit, if you just remember all of it? Elasticity we have mentioned in the previous class, na? It is the stress or it is the load up to which, right? Or elasticity, if you remember the property. What is elasticity? It is a property by which it can regain the original shape and these dimensions after removal of this load, na? Up to which point or up to which stress it will regain the original shape and size once the loads are removed? only up to the elastic limit, right? This regaining or recovering of this original shape and size will happen, right? But after that, complete recovery is not possible, right? Little bit permanent deformations are possible, right? Yes, no? So that is what elastic limit. Okay, next, what is this? You consider this is your C point. If you just observe, what is this C point? If you just observe, upper yield point, na? That C point is your upper yield point, right? UYP we call it as, right? And this is your which one? This lower yield point, you can say, written lower yield point, right? That D point will be taken as which one? Lower yield point, right? LYP. Now this lower yield point itself will be generally taken as this lower yield point itself will be taken as which one? Generally will be taken as this yield stress, na? Is that no? For material, right? For the material state, what is it you can say? That lower yield point itself will be taken as the yield stress, if you just observe, right? Mostly, right? Upper yield point, we don't take it as the yield stress, right? Lower yield point only will be taking it as the yield stress, if you just observe, right? Now, what is this? This is your D point, and this is your which point you can say? That is your E point, you can say, right? Now tell me, right, what is that D to E, if you just observe? From D to E, stress is increasing, sorry, strain is increasing, but is there any resistance you are having? Stress increases? No. No increase in the stress or resistance, but only that strain or this deformation is increasing, right? Like a water, if you take. So whenever you are having a water, na, just if you put your finger in the water, right, water will start flowing or not? Yes, no, absolutely. Even for zero force also, right, just if you pour the water here on the floor, it will start moving on its own, na, without applying any force also. Like that, what is it you can say? Plastic means, what is that plastic you can say? That is your plastic, even without any resistance or without any loading, that deformation or strains will be higher, right? That is your which one you can say? That is your plastic zone. Okay, so during this, it will not offer any resistance because its capacity got exhausted, right? Now E to F, what happens? Again it will start regaining regaining its strength by means of which one? This is a rearrangement of these particles, right? What is that? EF, you can say EF is nothing but your strain hardening zone, is not? That is taken as which one? Strain hardening zone, if you just observe, right? Yes, now can we take it like this? Yes, strain hardening zone means, right, what is it happening? During this plastic condition D, rearrangement of particles is taking place, right? Once the rearrangement of particles is over, na, again it will start gaining little bit strength, right? That is why stress strain curve will be start rising again. Now what is that F point? You can say, if you just observe, F point is your ultimate stress point. What is the F point? If you just observe, ultimate stress point, right? Ultimate stress point means, right, Fu is the symbol we are giving, na? So whenever you are having this Fy yield strength, Fu ultimate strength of a metal will be writing or not in our steel structures or anywhere else. So that Fu and Fy are given like this here, right? Now this is another point, right? What is this point? You can say that is your, okay, G point, you take it here. What is this G point? If you just observe, that is your breaking point. That is your which one? This is a breaking point, right? Breaking point means that breaking stress, now at this place, that breaking of this, breaking of which one will occur? Tell me, right? Breaking of this specimen will occur or not, right? Breaking of this specimen will occur, you can say, if you just observe, right? Okay, clear everyone? So here this is your stress strain curve for which one? This is mild steel, you can say. Now here 18th point, if we just consider it, what else we can consider here? So here in this, if you are just observing, right, how it will be changing from first to last. First, let us say your specimen is like this, is na? Your specimen is like this, right? At which point you can say, at this A point your specimen is like this, right? Breaking point means, right, where the cup and cone will happen, right, Shruti? breaking point FB is the symbol we are using for this breaking point, right? FB, F suffix B. Ultimate stress F suffix U na, yield stress F suffix Y na, breaking also F suffix B. The first letter of that sentence we are using to give for which one suffix. Okay. Now originally it is like this, right? This is the one you are having. Now by the time it comes to this B, D, E, what happens? Tell me. When you are increasing the load slowly, that deformation will increase, na? Length will be increasing, and what happens? Tell me. That length increases and this cross section decreases, na? Length increases and this cross section decreases like this, na? At which point it is possible? Tell me now. At this D point it is possible, na? At this D point it is possible like this, right? A, B, C, D, slowly it is increasing like this. Now at this E point, very large deformation you are having, na, right? At this E point, if you just observe, right, how much deformation you are having? Tell me. Very small deformation you will be having, or very large deformation is present at this E point? Very large deformation is present at this E point, na? Up to this, right, what is that you are having, right? Nothing is happening, right? Uniform increase is happening, right? Uniform increasing the length and uniform decreasing in which one? Uniform decreasing in the cross section, right? But now E to F, if you just observe, strain hardening zone, and if you just consider this FG, what is that FG we are calling it as? That FG we are calling it as this necking zone. FG you can call it as which one? This is necking zone, you can say, right? So up to E it is like this, right? But up to F also uniform increase only will be there or not, right? Yes, uniform increase in the length and uniform decrease in the cross section will be there up to this F point, right? But after this F point, right, what happens? Tell me. This is, let us say, F1, just if you consider. Yet this F point, right, what happens? Tell me. Yet this F point, right, that neck formation will be starting, na? What is that neck formation? Uniform decrease will not be there. So what happens, right, that central portion will start which one? This failure. Central portion will started failuring. It is started failure. It starts subjected to failure, and this kind of this neck will be formed, na? That is your F1, you can say, right? Now at this G point, right, what happens if you just observe? At this G point, right, what happens if you just observe? Tell me. At this G point, right, what happens, right? This is how this cup and cone will be formed, and yet this portion they will be subjected to this breaking, na? With respect to axis, how much angle they are making? Tell me. That 45-degree angle they are making with respect to the length of this member, na? 45-degree angle they are making with respect to the length of this member, you can say, right? So that is a cup and cone formation you're having or not? That cup and cone formation you'll be having. So cup and cone formation, and it is subjected to this breaking means, right? This is how it will be breaking, na? Yeah, whether we are drawing horizontally or vertically, does it matter? Tell me. Just how it is breaking is only important, right? How it is breaking is only important, right? It does not matter whether we have drawn this specimen horizontally or vertically, does not matter, right? Okay, just showing how it is. Okay, yeah, no problem, right? What is problem now? Tell me. Previously, yeah, I have drawn this diagram, very big diagram. I have drawn stress strain curve, and those specimens I have shown in the vertically, because if I draw horizontally here, space may not be sufficient. That is why I have shown vertically here. But here I have drawn in the next slide, so I have drawn in the horizontal manner because more space is available. Na? You can draw it in any manner, right? It does not matter, right? Only the essence you have to understand, right? That is important. So will anybody say that they will not give marks if you are drawing this horizontal? No, no. Whether you are drawing horizontally or you are drawing vertically, does not matter, right? It is the same representation only, right? Same we are representing or not, right? That is only important, you can say. Yes, no? Now, what is that gauge length we have to select? Tell me. What is the gauge length we have to select? Tell me if you just observe that gauge length GL is equal to that L naught will be equal to how much? Okay, I'll wait. First slide or second slide? Where should I wait? Okay. Note this and tell me. This is your cone, which is having this sharp edge. This is your which one? This cup, which is having this depression. Cup and cone arrangement. So now once the neck is formed, its a tensile capacity will start resisting it, or its a shear capacity will start resisting the tension. Its a shear capacity will start resisting the tension. It is not the tensile capacity will be resisting. Okay, is that clear? Note this and tell me. Then we'll write that gauge length formula and we'll close. Next class we'll discuss other things in the detailed manner. That true stress strain also we'll discuss in the next class only. Okay, done? Right. Gauge length, right? What is that gauge length? Tell me. It is the length over which we are measuring the deformations. No? It is the length over which we are measuring the deformations or not, right? Whenever these are your universal testing machine, jaws are there. If you just have right, yes, no? Universal testing machine, jaws are there. Now we will be keeping the specimen here, right? We will be measuring from the starting onwards to the ending, or we don't measure from starting to the ending. Tell me. We don't measure from starting to the ending, na? Over this portion, right? From center, over this portion only we will be keeping which one? This a dial gauge for measuring the deformations, right? This distance is called with which name? You can say gauge length, right? Why we don't take the entire length? Because these end portions are affected by the load mainly, or these end portions are affected by the machine holding or this machine influence is there, na? So that's why we are going for which one? You can say that's why we are going for which one? If you just observe, that's why we are going for central portion which is not affected by this machine, right? So that gauge length, how can you take that? 5.65 into that root A0. What is that A0? Tell me. What is the A0? Tell me. A0 is nothing but your which one? This is initial cross section area of this specimen before conducting the test. That is your A0. Initial means during a conduction of test or before conduction of test, right? Initial cross section of which one? This is a test specimen, you can say, isn't it? Initial cross section of this test specimen will be having, if you just observe, right, like that. Is it clear? Yes, no? Is it clear now? Right. So I'll be closing the session. Any doubts anywhere? Today we are discussing just for 20 minutes only mostly. And the next class on 16th we'll be having, na? That day we'll try to discuss 1 hour mostly. Yeah, time is there up to this actually. Just now I was closing the plus class, right? From 11 o'clock to this 1:10 I have taken the plus class only for 2 hours, right? That's why I was feeling little bit which one? Exhausted. Okay, so feeling hungry. Okay, so classes one after the other immediately are there, na? So that's why. Highway last class was there. Highway course, some classes were pending, na? One class, last class, that shock wave class I have taken today. Okay, thank you. I'll be closing the session. Thank you. Have a good day. Again, day after tomorrow, I'll try to take 1 hour. Okay, mostly.